This is a follow-up video on the Boulder 163. So on the previous video I said that it's not a deeper than origin puzzle, but actually it is. But there's more to the story, because you can think of it being deeper than origin in two ways. So the most straightforward way is by comparing it to the proto boulder, whereas you make these two turns, and now this is the turn you're making instead of the shallow one, because these turns keep the axes in place, if you think about it. So you can take this philosophy over to the Boulder 163 as well, whereas these are the cuts or turns you're making on a regular basis, and if you do these turns once and twice, you have lined these three of these around the triangle, and now you can make this 60-degree turn and the inverse on this shallow turn. So this would be the shallow cut and this would be the deeper than origin cut. But you can flip this all in your head, saying that this is a shallow cut and so is this. So as you're making a turn like this, which is shallow, the cut below is deeper than origin, because if you imagine these hexagonal contours, the planes they define, the origin is right between them. Not halfway, but definitely between them. So this cut and this cut is on opposite sides of the origin, so whichever you choose to be shallow, the other one has to be deeper than origin. But that's not enough to just say that. You also have to check for the axles or centerpieces. So if you consider this to be a centerpiece, where the axis goes like around here, when you're making a deeper than origin turn, you are leaving the other axes or axles in place. As you can see, that's exactly what happens. If you flip back around, all of these axes leaving in place is a bit more confusing, but on the other hand, much more similar to the proto boulder, so you have something to compare it to. But I think both of them are equally acceptable, and the fun thing is that it's, even though it's two cuts which are absolutely different in functionality, some of this cut type is always possible, this is only sometimes, but they have this abstract symmetry between them, but they can switch places in this weird way. So that's it for today.